Okay, today we're talking about some theoretical and experimental probability. I want to show you the difference. Telling you the difference goes like this. I would expect when you roll two dice that there's, like, let me think. You could get a 2 or a 3 or a 4 or a 5 or a 6 or a 7 or an 8 or a 9 or a 10 or 11 or a 12. That's 11 things that can come up. Why isn't there 12 things that can come up? Because you can't get 0 or 1, okay? But you could get 2 through 12. So there's 11 things that can come up. Is there a 1 in 11 chance of each of them? So you're saying that like a 5 might be more likely than a 2 of coming up? All right. I'd like you to try an experiment on this. Use your knowledge of probability to beat the system. Here is the system. You're going to get 10 pennies. You're going to place the 10 pennies on your iPad. You're going to number across the notability screen 1, 2, 3, 4. Oh, wait, we don't need 1, do we? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you want to kind of stretch it all the way from one side to the other because you're going to place pennies on these numbers. You're going to kind of try to predict which ones are going to come up. I know you don't know. You're giving your best guess. But your goal is to get these 10 pennies off of your game board. How do you do that? Every time I roll one of the numbers, you get to take 1 off. So like say you have, let's say you crazily put all your pennies on the 10. Even if I roll a 10, you only get to take 1 off. So don't just assume that you get to take them all off when I roll that. You get to take 1 of them off. But what if you have all your pennies on the 10 and I roll a 7? Do you get to take anything off? No. Only if people who had a 7 get to take 1 off. So you can place your 10 pennies anywhere you want. Right now you're just getting your numbers straight. I'm going to pause the video while we get this set up. Okay, so we played a little game there to practice probability and kind of just get a feeling for real experiments in probabilities. And when you do it for real, it gives you better perspective than when you're just theoretically figuring out the probability. The main thing to remember with dice is there are 36 things that could happen. So if I said on the test, what's the probability of rolling a 2? How many ways are there to get a 2? Only one way, so what's the probability? 1 out of 36. What if I said what's the probability of rolling a 7? You'd want to list all the possibilities. How many ways can I get a 7? 6 ways. What are the 6? A 2 and a 5 makes a 7. What else? A 5 and a 2. That does count. What else? 3 and a 4 and a 4 and a 3 and 1 and 6 and 6 and 1. And those are different. Think of them as different colored dice. This is like a white one being red and a 1 and a red one being 6, vice versa. They're different colors. So there is 6 of them out of 36. 6 out of 36 chance. 7 is the most common thing. 6 out of 36 is the most common. 1 out of 6 chance. All right. So every 6th time you roll a dice, you're going to get a 7. False. But on average, every 6 rolls or so, you should be coming on a 7. All right. Independent versus dependent. If I were to do a card trick here with these cards, and I say, this isn't a trick, it's just a simple one. Pick a card, any card. Now, what's the probability that she just picked a club? 1 in 4. Also, how many clubs out of how many total? 13 out of 52. Good. Now, did you get a club? She did not get a club. So now, if I have her pick again, does it depend on what she got last time? Yes, because she kept it out. So now what's her chances of getting a club? 13 out of 51. Okay, try again. And did you get a club? No. Now what's her chances of getting one? I think you get the idea. Okay, and that's dependent. If I'd had her put the cards back in every time, then it would have been what? 13 out of 52 every time, and therefore what word? Independent. Okay, good. Moving on. This one is probability of Female achieving only a high school diploma. No, it says only a high school diploma. All right. Did it say I could only pick from females? Read it carefully. Did it say that? No. So everything was possible. So it's out of what? 3172. Then, what are the things that make you, quote, win, or the thing you want to happen? Females, high school diploma, right there. 232 out of 3172. A lot of people think, but doesn't it say you have to pick a woman? No, it said the probability I will pick a woman who has a high school diploma. Okay, so if they had said you could only pick from women, then of course it would have been 232 out of 1602. All right, this one. At least some college education / male. Has anybody caught on to what the slash means? Not out of. It does when we write them like this, but this means given. Given male. Would you please write down what probability you think that is? Given that it's only males chosen from at least some college education. All right. I hope you knew to pick only from this column. And I bet a lot of you did it wrong. Here's why. At least some college education. I bet a lot of some college. But it says at least some college education. Wouldn't these guys have some college education? Wouldn't these guys also have some college education? Yes, so you should have put all of those together and added out of 1570. So 374 plus 463 plus 382, all divided by 1570. All right. And this one, last one, probability of a woman given, we only pick from achieving only a high school graduate, meaning only high school graduates. That's only this column. You get how it said only that? That's why you can only pick from those numbers. Now, what is it? The probability of a woman. So what I want, since I can only choose from those three numbers, that's the women's what I want out of that. So 232 out of 537. Raise your hand if that made sense to you. Okay, good. Moving on. Say that there are two four-sided dice. It's kind of a pain to write all these things out. Do you get that there are 4 things that could come up on a four-sided die? 1, 2, 3, and 4. See, this is actually a picture of one. You can't see 2 of the sides, but there's the back side of that triangular looking thing, and then there's the bottom that's where it's laying on the carpet or whatever that is. Okay, so there's 4 sides to the die. If there's 2 dice that have 4 sides each, hint, when there was 6 sides each, how many total outcomes were there? 36, so how many outcomes here? 16 when you multiply them. So there are 16 outcomes. Then that's what's possible. What do we want and should put on the top? Probability of getting 6 or lower. Well, there's a whole bunch of those are going to be lower than 6, so maybe we should think of it the other way around. There were 16 things, but some of them aren't going to work, right? How many of them aren't going to work? Would you agree that the 4 and the 4 being rolled is not a sum of 6 or lower? You get what I'm saying? What else is not going to work? 3, 4, and 4, 3. Those are all out. Is there any other ones that are out? No. So then, if those are out, how many things would be 6 or lower? How many things would be lower than those? 13. So 13 out of 16. It's what you want over all the possible. What you want over possible. Try to keep remembering that. Okay, next one. This is that area model. So to do this, we got 12 and 8 makes 96. That's the area of the whole thing. You always need the big area because that's what's, say it, possible. Thank you. 96 is what's possible. What do I want to hit here? The triangle. And what's the, is that 40? 20. You take 5 times 8 is 40, but you cut it in half. 20 out of 96 chance you're going to get the shaded region. Does that one make sense to you? Okay, moving on. If you really need this during the test, you can ask me and I can put it up. It will be a reminder of what are the cards that are in a deck. Now I'm going to ask you some questions about it. Given that I'm only picking from the red cards, what's the probability that I would get the Queen of Hearts? You get there's only one Queen of Hearts? 1 out of 52? Why did you change what was possible? Because I said, given it was only the red cards. Only one Queen of Hearts, though. I know you're thinking red Queen. Now I said, I said red cards. Does that remind you that there's not just 13 red cards? There's 26. 1 out of 26. Okay? If I'd have said only picking from the hearts, that'd be different. All right, I'll say one like that. Only picking from the clubs, what's the probability you'll get a jack or higher than that? It is higher. Good question, but the way they're lined up here, I was hoping you'd notice it's a lot of games it can play as a high card or a low card, you get to pick, but anyway, we'll just say it's a high card or a low card, and so you get to pick, so we'll say it's high. 4 out of 13 then. All right, given that it's not a club, what's the probability I picked the 7 of hearts? Given I did not pick a club, I would guarantee you that. What's the probability I picked the 7 of hearts? 1 out of 3 sets of 13, which is 1 out of 39. Very good. Because there's 39 cards. Because I said you couldn't get a club, so it couldn't be those. The rest of them was 39 cards, 1 out of 39. Okay, good enough on those. This one, if I were you, I would make a little tree for it. So make yourself a little tree here. And why am I only doing 2 things? You're either going to get a club or not a club. Okay? So this is club, and this is not. What's the probability you're going to get a club on the first draw? How many clubs are there? Out of how many total cards? There you go. And what's the probability you're not going to get a club? 39 out of 52. Good. Now, does the next part depend? It says you do not replace the first card. Yes, it does depend then. So it depends. If I got a club, which is going down this road, I got a club, then is my chance of clubs the same? No, it's different now. What are the probabilities now? 12 out of 51. Good. And this one is, how many other cards are there? So this is not a club. There was 39. Is there still 39? There's still 39 other cards because I got a club. I know because I went down this road. 39 out of 51. Does that add up to 51 out of 51 when you add them together? It's another way to tell if you did it right. These have to add up to 100%. Get what I'm saying? All right. Okay, I think you get the idea there. Once you've made your tree, then the probability of picking 2 clubs. Well, actually, I probably wouldn't have needed the tree, but here it is. There's the first club. There's the second club. I went down that path. I just had to multiply those 2 things together. All right. And Weatherman Jeff. He used to be a weatherman here at Minnetonka High School. Now he's actually a real weatherman at Care 11. The guy who we currently have as a weatherman, I want to go on record as saying he's probably going to be a weatherman somewhere. He's really good. I probably have noticed that. Oh, that's right. At least the current weathermen are really good. So I bet you this will happen again. But our weatherman here is a real one now. So imagine for a moment that you had to do probability of 2 days of snow. Then do you get the first one is like a tree where it's snow or not? And that's 24 snow and therefore what not? 76. Because you just have to add up to 100, right? 24 snow, and then another day of snow means snow again, but the second day's snow is 35. How do you get snow, snow then? Snow, snow. What do you do to those two numbers? Multiply them. All right. This one says, given it snows the first day. Is that changing things? Of course it does. It's no longer everything is possible. Now it's only possible that it snows the first day. This isn't a choice anymore, but I'm only here. And now what's the probability of, wait a minute, 1 day of snow? It already snowed. What's the probability of that? 100%. All right. So now, if I change this to 2 days of snow, then I'd say it's just what's left, which was a 35 and a 65, right? And if I want it to be this one, it's just 35 because I already know the first part. All right. So this will be a challenging quiz for you. I know from the past, kids have trouble with the trees. This is not an easy one. Strongly recommend you do your homework. Even stronger recommend you check it. Just doing it alone isn't worth it on a night like tonight because you don't know if you're doing it right. Check it. And if you're having major trouble with it, study. Go back, watch the videos from the last couple days over again if you need to. Because today was just a review day. If you want intensive practice on one thing or the other, the videos I did before will probably be a good one. All right, that's all I got for you for today.